Hey everyone. I thought that this could be a tutorial for the plate motion simulation just because I think that this website is a little trickier to navigate. I tried to put my face in the corner, but it keeps covering up some of the buttons and then they don't work. So we'll just do it by voice. If you look at your directions or if you took a look at them, the first direction that I give is to click on this left arrow. And notice when I hover over it, it turns it red. So when I click on it, it also highlights the right facing arrow red. So plate 1 is going left, plate 2 is going right, which means they're pulling apart, which creates a divergent boundary. So I'm going to click on See Plates Over Time, and notice it says divergent boundary up here. Before I pick my time, I want to show you the legend, make sure you understand everything. See this coloring? It matches this rock right here, so that's continental lithosphere. If it were darker, it would be oceanic lithosphere, which just means this is land, and if it were darker, it would be water, okay? We are going to look out for some melting rock. The yellow arrows show us mantle convection, which means this red layer would be our mantle. And then we're going to keep our eyes open for earthquakes, mountains, volcanoes, underwater volcanoes, riverbeds, and abandoned riverbeds. And when it's time to write in our data table, whether you are writing on paper or if you have a digital, if you're doing it digitally, I will switch back and forth between that. So you can do the same. If you want to pause the video and switch over to your paper to write, you can do that also. Okay. So the first thing I'm going to do is I'm going to pick my time. I'm going to choose 10 years first because that matches my data table. And then I'm going to click run and watch very closely because it doesn't take very long. So if I click that, watch that again. That is ridiculously small. So if I watch, nothing really happens. So in my data table, I'm going to write none because after 10 years, there were no changes to the land. And after 10 years, there was no changes to water either. There was no water there at all, really. So I'm going to write none. Okay, next is 100 years. So I would go back to my simulation, reset my time, choose 100 years, and now click run. What happened? What did I have here? You should be saying to yourself that you saw an earthquake. So on my data table, I am going to write that I saw a single earthquake. Okay? And you might even say that there was a slight spreading of the lithosphere. It just began to spread apart. We still didn't see any changes with water. Nothing really happened with water there. Okay, so you can go ahead and fill in your charts. I will go back and I'm going to reset my time. I'm going to do 1,000 years this time. So if I start from scratch and I run through 1,000 years, now I have multiple earthquakes. My convection currents are still happening. Do you see the little dip right here? Can you see where the magma is starting to just push up through the plates? Okay, so we might want to write that down. So where it changes to land, I would say that there were several earthquakes. Okay. I would say there is a slight rise of the magma between the plates. Okay, it just started to poke up there. And then we still had no water changes. All right, I'm going to go back to my simulation, reset my time. I am now going to do 1 million years. So let's see what happens. Okay, in 1 million years, I have more earthquakes, right? And then the magma increases, it pushes up into the center a little bit further. And look up here, I'm starting to see an indent up here. See how the little line dips down? And whenever you have an indentation in between two flat plains, we call that a valley. Okay? Do I have water? No, still no water. So I'm going to go over here. I'm going to again say several earthquakes. I am going to say magma pushes up further between the plates, and a valley forms on the surface. Right? Still no water. Now, when I go back and I do 5 million years, reset my time, 5 million years, starting from the beginning, watch what happens. Earthquakes, convection currents, magma pushing up, the valley forms, and then what? Look at that. Okay, so after that valley forms, look here that I am starting to get that magma chamber. My magma is pushing up to the surface, and they're trying to show you that little bit of steam coming out of there. So we have the beginnings of a volcano, and see this blue line. Your valley became low enough that we now have a riverbed. Okay, so we can add that to our chart. So at where it says where it says 5 million years, I am going to write many earthquakes, not many earthquakes. I am going to write that the magma rises to the surface. I am going to say that there is a valley on the surface. I am going to say that new lithosphere between the plates is forming between the plates. And you have the beginnings of a volcano. Nothing major, but you could see the steam escaping. And then I would say that a small amount of water appears in the center of the valley. I'm going to put in parentheses here, river. Okay, it's not a ton of water, but it is there. Okay, so what's left is 20 million years. So I'm going to go back, reset my time, pick my time, go to 20 million years, and I'm going to run it this time. So from beginning to 20 million, what happens? Earthquakes, mantle convection, magma pushing up to the surface while it's on its way, valley forms. Magma reaches the surface, start of a volcano, you have the riverbed. Look what happens in there. Do you see all the volcanoes and popping up in the water? Okay. So now I have my underwater volcanoes. I have volcanoes out of the water, sticking out of the water. This darker oceanic lithosphere, so I had new crust that was made. Water that what started out as a small stream is probably now more like an ocean, because think of this, if I have a volcano, it's not going to occur in a stream. You need something a lot larger than that. So let's add all of that to our paper. So in 20 million years, we have a lot of earthquakes. We have underwater volcanoes. Along the boundary. We have 2 large volcanic islands. Right? And then the oceanic lithosphere is clearly visible and spreading. Okay. And then for the water, that valley fills in with water, creating an ocean. And I'm going to stick and say that it's ocean just because it's so much water that it holds a volcano. Okay. So then next we have to do transform or sliding plates. So I'm going to go back to my simulation. I'm going to go home. And this time I'm going to choose my up arrow, which highlights my down arrow. And I'm going to click see plates over time. Now for this one, we are not going to work ourselves through. We're going to jump straight to 20 million years because we should have at this point realized that this stuff happens really slow. So it takes a really long time to see a big effect. But if you take a look with where we're starting, we have two plates. They are continental lithosphere. And this time I have a river running across. So watch what happens in 20 years. Okay, so in 20 million years, we saw our plates move, and because the ground moved, we had lots of earthquakes. My riverbed moved. So the water pushed through the new spot in the crust and created a new riverbed, and the old riverbed no longer has water going into it, so it becomes an abandoned riverbed. But that's really all that happens. So on our chart for that one, we're going to say that in 20 million years, we had many earthquakes along the border or along the boundary, right? And that's really it. That's all that really happens to the land. In terms of the water, we could say the direction of the river begins to change, mostly because the plates are moving, right? And it eventually changes its course. And you could actually say the old course becomes an abandoned riverbed. Okay, so I would add that to my data table. Okay, we need to go back and finish the last two, but this program only lets me record 15 minutes. So I'm going to end this one here, and then we will pick up with the convergent boundaries in the part 2 video. Okay, so I will see you in a second.